We are really glad to welcome you here in our office in Atacama. Thank you for all to join us today. This is my slides. They are available by the link because I have my own personal pain of bad eyes, so I cannot see some small text. So maybe if you have the same issue as you can just take a look inside some small text and avoid these problems. But if you don't have such an issue, you can just move to the slides itself.
Sorry, scanning your QR code made by you.
Yes.
I'm not sure if
yeah, it's made by me. So if you don't want, you can just avoid it and don't make it. Today my topic have a pretty stupid name. I would like to apologize for it in advance, and I will explain it a little bit later. So we will talk about today the JSON web tokens and the way how they signed. But we will not talk about the common one, as you may have known, about the GVTs. We will talk about the different one. And we will talk about different frameworks that usually innovate the wheel. Sometimes this wheel were introduced before the JSON web tokens, like Tornado, etc. But they are using the different way to save the same data, but in the different format. And as I promised, we are moving to the name of these stupid presentations. And it's taken from the name of this framework. It's called the It's Dangerous, and the second name, so better to sign them. And this is a problem of this framework. The way how they sign something is sometimes cause a lot of problems. And because this Python framework is really famous and used around the big number of projects, it was really unfamous. And it's, I would say, last 2 or 3 years, it was the biggest thing in the bug bounty hunting. It was like the race when you are trying to hack something, get the money, and the huge number of researchers are doing the same. So you like on the red race because they are submitting the reports simultaneously with you. So it was pretty nice competition on the time, because if you miss the time, you miss the bounty. And it started with research about the Airflow. What is Apache Airflow? This is a special website that allows you to create a small workflow automation. So you can connect a lot of different sources, like AWS, etc., and you build the automation on it. So, for example, you will create the Python code. They call it is not the code itself, is DAGs. It's something like the data asynchronous flow. So something like these diagrams. And these diagrams allows you to build automation above it. So what's the issue, vulnerability that was discovered? By default, they are using the secret key. This special magic secret key allows you to sign the cookies. And this cookie is stateless cookie. What does it mean? It means that it saves all the information that connected to the user, about the user, all of its metadata, not on the server side, but on the client side. And that makes the things really bad. So let's take a look on some details about how the Flask, this framework, and its dangerous under the hood library works. So this signed cookies is some session metadata, time step, and the signed things. That's make it secure, signed secure. In theory, of course. So let's talk and funny pictures. So the first part, the red one, is sometimes can be base 64, as you may recognize with these funny AY symbols. We will use them a little bit later to find our vulnerable web servers. And then after the dot, this is a timestamp. The timestamp itself can be calculated different ways, but never mind. Right now, it's not so important. The more important thing is the sign. This is SHA-1 signature that will be calculated above the first two parts, plus secret key, plus salt. All of this together will be transferred to the client side. This client side, like our browsers, will save it, and you lately can use it to send back to the web server. But what makes the things worse? If you are an anonymous user, you don't have any kind of session, the framework itself is so kind, it will create the anonymous cookie and will sign it with the same key. And this is why the problem arises. Yes, because if you use the same cookie for the anonymous user and for the authenticated users, someone can brute force it. And this is how it works, attack in theory. So let's talk a little bit about this session data. So as you may see, there are a lot of funny attributes like login false, because I'm an anonymous user. If I would like to change it login true, so it will not simply work, because I should have access to the salt and the secret key, calculated with my new session metadata, timestamp, and get the new signature. But right now, let's take a look on these attributes of these claims, what we would like to present to our vulnerable web server, how we will work with it. Timestamp. There are some, I would say, things about this framework. The way how it calculates the timestamp was changed, but it's not so important, because the major thing you should know is usually these cookies valid for the 31 days. So you have a pretty lot of time to brute force them, to be for sure. And once again, this is SHA-1 cryptographic hash. So it's pretty nice because you can really easily brute force it. And we move to our unfamous temporary key. This is exactly the key that Apache Airflow used. And this is what about this CVE is about. So if you will take this temporary key in your Docker image, get this admin session cookie, and just copy paste it and put it to any random web server in the internet, you will get access as admin. That's it. It's pretty simple. You don't even have to do something. You can just copy paste the cookies. This was the most stupid things about this vulnerability. So the guys, sorry, I forget the name of the company, but I do really apologize. They created the Flask Unsigned tool, and it's a pretty simple tool that will take a huge list of pretty known bad these secret keys and try to brute force them. What they did, they collect these secret keys from the GitHub, Stack Overflow, Google Docs, etc., and put it inside the different separated repository called the Flask Unsigned word list. You can use it right now, but your results will be really poor because everyone has did it already. You have to be innovative. You have to figure out different way to find the secrets. And as an example, you can use, for example, Google BigQuery, because Google BigQuery, as you may know, have a big BigQuery data about not the most, but a kind of huge number of GitHub repositories, and you can scrap this data for these secret keys. So it works pretty simple. You just put the flags U and C, and it's break the things. So it's pretty simple. It can be done even inside your terminal. So this is how it usually works. You just grab the login flow and get inside of it with unsigned and cookie key. Let's jump to how to forge the cookie itself. It has the special another parameter called the sign, and you put the secret and the sign something. And this will be our major way how to break the things in a couple of few more examples from the real world. So a couple of words about the RECON itself. Once again, the Luke Paris, who designed the Flask Unsigned, introduced the way how he did these RECON statistics. He just grabbed every single server on the showdown, call the Werkzeug, sorry for my German, and where is the cookie sets the session itself. But unfortunately, right now, it's only bringing you not so many results. But if you will just switch to the census search framework, you will get a kind of more session informations. And one small announcement. There is kind of problem itself. Yeah, we are relying on this web server Werkzeug. But what if someone have implemented inside of it Nginx and filtered out that the web server is running and you don't even know how to find it? So this is the way how we will break the things. We will use this session data and know that this was base 64 encoded. So the first two characters always will be E and Y. Of course, if they do not implement some kind of encoding. When we are talking about the Flask framework, they are using the sleep compression, deflate, if you're familiar. It's almost the same. And you will need to search .e, and this will find you the same session cookies. And you will get better results, much better results. And if you will take a look on the first position, it will be around 60. And the overall, I would say, the percentage is around 30% of the whole session tokens you will grab, you will get valid right now. This is information from the last couple of days. So it's still a big problem to the whole internet. Let's take a look one by one. So super secret key. Come on. Where is super, where is secret, where is key? And where it's used. It's used in some kind of template engines. So you can create the, I would say, the your content management system or something, another web interface with this one. And I usually break the things with admin LT. This is the same Flask template engine, but the same cookie cutter have the same logic. And it works pretty close to the Apache Airflow. You just have to change the ID and the user ID. And if you will carefully take a look, there is a small first leading dash before the user ID. And you have to forge your session cookie with this dash user ID and then the user ID itself. Usually we forge the first one because it's usually the first user who will create it will have the ID 1. But sometimes you will find that this can be 2, 3, 4, 5, and whenever else. For example, if the administrators after installation would like to delete the default credentials, they will usually delete this admin user and left all the another real users. So I would recommend to brute force from the 1 to 10, and you will get a pretty nice results. Power DNS. This web server is responsible for the management of DNS records. And it's another pretty famous secret key. Their own secret key is pretty huge one, but they have another problem. Of course, they do not use the default one, but the Docker Compose file that they are distributing, it has this default predefined key. And no one, to be honest, changed it. Even if they have a big warning on the first page, hey, please take attention and change your secret keys. No one did it. And if you are interested, it's pretty long one, but it still can be exploited with the same leading dash user ID. And this is just a pre-example how to forge the secret, not secret, of course, session cookie. SUPERSET. This is a pretty nice example how a lot of security researchers was trying to break the same thing simultaneously. Because a lot of security groups have reported them not only to the SUPERSET developers, but to the multiple companies. And the SUPERSET was trying to fix the problem. The team of SUPERSET was changing this secret key around 4 or 5 times, trying to somehow mitigate the risk because people were deploying over and over again with this hard-coded secret key. And never works what kind of announcement you will put on your main page, please change this defined secret key. And this is the first one. And you can exploit it pretty simple. It's just the same user ID. What makes the things worse that the super user, admin user, can change the settings of the SUPERSET framework. By design, the SUPERSET have credentials to get access to the databases. And only the super user, admin user, have the rights to change this, let's say, the database configuration. And this will allow you to run any arbitrary SQL queries inside the SUPERSET itself. And this is the way how to do it. They call them DML. It's not so important. The most fun part is on the right side, is where you can see this SQL query. So if you will just create the new table, put usually it's predefined, deployed with Postgres. So this is demonstrate how to execute remote code execution inside this Postgres database. You will just run the copy command exec from program whenever you want, and you will get the shell to the database. And this is the whole history of what the guys was trying to do. They were trying to change it to a complex random secret key, your own generated random secret key, any another non-development environment, etc., etc. And they finally released the patch. And the patch was designed to prevent the web server to start at all with default secret key. Until you will run the command and generate your own one, it will not start right now. Some another funny statistics. This one don't have any pattern of it, so you cannot imagine what kind of framework behind of it. All of these websites are using their own logic. But if you will use the same methods I described above, and will try to change the ID, user ID, dash user ID, dash ID, isadmin, etc., etc., we'll talk about it later. And you most likely will forge this admin or non-admin session. Redash. Redash have the same problem, but a little bit different way to exploitation, because the way how they sign this, not the cookies, but let's say the tokens, it was a little bit different. Let's take a look in details. This is the default secret key, and it's defined with Redash cookie secrets, and it's pretty easy to Google inside the all Docker Compose images you will have. Yeah, you can try to forge it with user ID, but it will not work on every single version of Redash. But what will works is called the reset token. They use the same secret key to generate the reset password token for every single user. What are they doing? They just take this ID, put it in the first part of the session token, and then sign it with the same It's Dangerous library. The biggest problem of this approach for us as an attacker, we cannot use the Flask Consign tool, because Flask Consign do not support this configuration of It's Dangerous. First of all, it will use different salt, and second one, it will use the different serializer, let's say it, because the signer itself is always the same, but the way how we serialize data in the session data part of the cookie is a little bit different. And this is just the name of this serializer. I'm not sure it will give some ideas to you. But if you will just run this tiny Python script, you will get the admin session reset token. You will just visit the Redash, change the password to your own, and get access to the Redash. And we finished with the first part, and this part was about the Flask framework. Another good example is Octosample application. And they are using not only the Flask framework, but the Flask framework with OpenID Connect tool. This OpenID library, if you are not familiar, uses the JSON Web Tokens to store information about the user. This information is pretty well known because the OpenID standards describe these claims about the user. And if you will crack the Flask session with your own something not entirely secret cookie that are pretty usually used by the Okta, because Okta published it inside their sample application, and they hard-coded it. I contacted the Okta, they changed it, and right now they do not use it at all. But if you're using the first version of this sample, you will still most likely will be vulnerable. So what did the Flask OpenID Connect library? It will take the same secret key that is used for the signing of session, and if you are able to guess the secret key from the Flask session cookie, you will use the same secret key to generate OpenID Connect profile GVT token. And with this token, you will be able to log in inside the vulnerable application. So it may sound a little bit difficult, but the exploitation is pretty simple. You just grab the same secret key, put inside this simple logic, and you will get the GVT token. Couple of words about OpenID. If you are not familiar about this framework, not framework, this is something, the stack above the OAuth flow, yes? So it's some kind of technology above the OAuth, how you will introduce the person itself. So what you will need, most likely, is just to guess the name of the person and email, and because usually these OpenID frameworks will check that your domain belongs to the company domain you would like to hack. So you have to change this domain name in your email address. But sometimes you can just get inside of with any random email address. Java. Even it sounds the same like the Java. It's not Java. It's Jamf web application. What does this Jamf? If you are not familiar with the Mac world, there is a huge security company that provides the security service for the Mac infrastructure. It used to something like the device management software company. They will roll out every single security settings into your MacBook, iPad, iOS devices, etc. So they introduce this webhook system. How it works? When you edit every single device into your Jamf professional cloud, it will sense the webhook. All of the information about the MacBook will be sent to the cloud to this Jamf professional, your instance. And this tool allows you to run some kind of automation about it. So let's consider some like webhook servers. And they are using the same Flask framework with the secret key with pretty nice value. Usually it's just asterisk, just one sign, just to make the things much easier to hack. They changed it lately to the anti and then completely get rid of it. So how it works? You will create this admin session with the Flask application. It doesn't matter what kind of ID do you have. The only one thing they check that your user entered the password. That's it. It's pretty simple. You entered the password, welcome. You will create the cron job, and this cron job can be any Python script. And you can just create the reverse shell from the Java, this Docker image or any else where it's running, and you will get directly root access, just because. And this is just a small video about how it works, but nothing novel. So you will just copy paste, send, and wait for the pin back. I'm not sure if it's able to zoom. No, sorry. Yeah, and because of it is a cron job, you have to wait the beginning of the minute. So sorry for kind of late. But here you can see just get the ping back from the server. Express. And we finished with the first part. First part is called the Flask applications, Flask framework, and is the dangerous part. And if you have heard carefully, you will notice that some of the sessions we were searching for can be set by different frameworks. Usually, you will get the same AY session cookie, and you may be surprised why they cannot be just unsigned with Flask unsigned tool. Because usually, different frameworks use the same convention of naming for their session cookies, the same as using the Express. And they have the same session cookie, which is the JSON Web Token, but they're using a little bit different way to sign it. They are relying not on the ID of the user inside of the cookies. They usually rely on the passport. And this passport usually defined inside the cookie session library. And this passport is, I would say, the pair of key value where is the key is username or value your username. It can be admin, administrator, user, etc., etc. So how it looks? It's not the one session cookie. They have the two session cookies because two session cookies is better than one session cookie. First one is session, and second one is session signature. How it works? It took the first cookie and the whole cookie, I mean the key equal value, create the SH1 signature and put it into the session signature cookie. And if you are able to forge your own session cookie with something user administrator, you will get access to the application. And this is pretty simple way how to exploit things. You can write a pretty tiny Python code that will do the same. He will just take the secret key. We can take the same library we used before, like Flask unsigned word list, and try it with this one, and try to break the secret key, and re-sign our new session cookie with a new username, and get access into the application. RECON. RECON is pretty simple, but you will have to change to the session.sign something, and try to grab as much as possible. Once again, sometimes some frameworks not using the session world itself. It can be, for example, expression, session. And it's kind of confusing. Yes, they can change. So I may miss something when I was doing the RECON. And the most popular one is the magic. What is it? It's parse server. What is designed for? If you are, for example, a small company and you don't want to run a big, huge backend, you can implement some kind of GraphQL or REST API in this parse server that can be run on any JS frameworks. For example, they suggest to use the Heroku for these purposes, deploy it here, and it will work like your backend. What the biggest problem that usually you will get access to the all information about of this tiny application. Usually it's Internet of Things application, mobile devices like Android, etc. And you will get access to all users of these applications, mobile applications usually. This is how it looks like. It's pretty simple, as I said before. You forge the session with user, administrator, user admin, user 1, user 2. I have no idea why the parse server suggests these usernames, like user 1 or user 2, but it usually works. It's a little bit broken. Just give me a second. Great. This is another good example. Itself, the Microsoft authentication library, it's not vulnerable if you're using it like it's suggested. So they suggest you to use the securely generated secret key replaced inside your configuration server. Never store the secret inside the code, etc., etc. But if this Microsoft authentication library will be used with the same cookie session framework, it will produce some kind of problems. What the problem is itself? This Microsoft authentication library usually suggests you to use something like isAuthenticated user flag as soon as all of these OAuth flow have finished, and you will put this flag inside this session value. And for the malicious user who can break the session secret key and forge the isAuthenticated user, it will raise a problem. How it looks like? If you will create some middleware that will check the user is authenticated, it will check only this flag itself. I will show you more examples. For example, this one will show you the bad program itself, because is authenticated middleware will return you true because this flag can be easily forged by the malicious user. But otherwise, this one will not work because yes, it uses this is authenticated user, but lately it will use your access token grabbed from the Microsoft, for example, microsoftonline.com login. Yeah, login microsoft.com. And you are not able to predict other users' token, but you will at least get access to part of application. Of course, not to some kind of sensitive ones, but who knows? It really depends on the application. And this just from the example taken the same. I did a little small research about the most common is authenticated flags inside this session in the GitLab and GitHub, as I said, with Google BigQuery engine. So you can try to play with this one if you are able to guess the sign-in key. Another framework is pretty old one, and this part I would say is legacy, but it's worth to mention because they still can be met in wild internet. Another is Python web framework, and they are using the same signed cookies, but the way how they generate these cookies is pretty funny. It deserves to show you. If you are able to see, first one is the name of the cookie. Second one is the timestamp when it was created. Third one is, once again, the name of the cookie. Fourth one is the content of this secure cookie. And the last one is the signature. So usually the most interesting part is the colored with red. It's usually the username, name, display name, something like this. It really depends on the web server who was designed by the developer, what he will put inside of this JSON token, but it's up to you. The way how they calculate signature is pretty the same. They will take everything before the last pipe char and calculate with the secret key the SHA-256 hash. I was searching just by the Tornado server and 1:0 because I was looking only for the second version of the Tornado cookies. But if you are lucky enough, maybe you will find the first version, but it's more older than the second one. And once again, it doesn't really mean that I cover the whole internet because some of them can strip the server information. And it's not so funny because the only one thing I was able to find is just this pretty long default secret key. If you will grab the GitHub itself, you will find a lot of tutorials about this default secret key, but not any big framework or big application that uses on the wild. So it's only around 13% of the valid sessions right now. Django, last but not least, and it's worth to mention because I would say this is the oldest one thing that is used. And it's pretty well known that the Django have the same signed cookies. But they have a pretty nice thing inside of their own cookie engine. It's called the pickles. If you're familiar with Python framework, this pickle serialization and unserialization mechanism allows you to store inside the cookies the whole object. It's not only about the JSON, it's about the code itself. And they have a big, big announcement. So if you are using the sign-in cookie and the pickle serializer, you are in a big, big danger. How it was exploited in the wild previously. There was RC vulnerability inside the Sentry because they use the same methodology. They have the signed cookies and the pickle serializer. And if you can get access to the secret key, for example, enable debug mode on your web server, you will get the RC. It's pretty simple exploit. You create the pickle RC object. When this object will be deleted, it will execute the code on vulnerable server. And we are going to the final part of our presentation about the recommendation. I would say the most funny thing about all frameworks is SUPERSET. The way how the guys was trying to mitigate the risk of continuously rotating the secret keys over and over again, publish them into the internet, and get hacked over and over again, show us the only one way we can do it securely. Do not start your server and your application until you generate it securely, ideally by some Python code like put this UID inside your secret key. That's it. That's it from my side. Thank you. If you have any questions, yes, sure. Just give me a second. I will try the magic, but maybe we don't need it.
You scan GitHub source with BigQuery, right?
Yes, exactly.
And then when you find projects, how do you classify them? Like which are interesting, popular, which are less?
I would say this is opposite way. So you scan with Census framework the all known session keys, and you get something interesting. Of course, there is another way. Yes, we can just collect all the secret keys and put them inside our own world list. So it's up to you. You can do from different ways. So if you would like to start with the BigQuery, you just scan for the secret underscore key, and all of these values put inside the word list and inside the Flask unsign. And you will see by yourself which one is triggered more often, and you will take attention to this project in the GitHub and take a deep dive inside of their source code, how they work with these authentication authorization methods. Anything else? Thank you. Oh yeah. Oh yeah. I will grab.
Are there any frameworks which treat it as a dead end? Like, no luck at all?
I would say that Tornado and the Django itself is the most unlucky way. As I mentioned, with Tornado, I was just able to find 10% of them. And all of these applications are just student projects. So you will not find any serious. About the Django itself, I was able around grab 3,000 or 4,000 session tokens and only 2 findings. So I would say the Django is the most mature one, and they have the biggest history and the biggest support from the Facebook. I believe the way how they communicate with developers, or maybe they'll educate the developers, works much, much better. Thank you.